So now we will discuss EIGRP tables. EIGRP maintains 4 tables. The first one is neighbor table. Neighbor table. Second one, topology table. Third one, routing table. Fourth one, interface table. First we will see neighbor table. See R1, show IP EIGRP neighbors. This is neighbor table. 192.168.13.2 and 192.1.12.2. There are two neighbors. See here hold time seconds here, 10 seconds and 13 seconds. This hold time is used to track neighbor availability. When R1 receive hello packet from 192.1.13.2, this hold time reset to 0. Reset to 15. Again it will start from 15, 14, 13, 12.1, 12 and 1. EIGRP sends hello packets every 5 seconds, right? So 192 R1 expecting hello packets from 13.2 for every 5 seconds. When R1 receive hello packet from 13.2, here it will reset, it will again start from 15, 14, 13, 12.1. Same, when R1 receive hello packet from 12.2, it can start 15, 13, 15, 14, 15, 13, 12, 1. See here, see 13, 14, 14. See here, observe these timers. Okay, this is neighbor table. Second table is show IP EIGRP topology table. This is topology table. This topology table maintain primary and secondary routes. See here, from R1 to reach 192.1.2.0 network, from R1 to reach 192.1.2.0 network. Okay, listen carefully here. From R1 to reach 192.168.2.0/24 network, R1 has two routes via R2, via R3. This is the path. This is also another path. Here R1 has selected via R2 as best path. This is my primary path. Via primary, this is primary path. See, if you see the routing table, it shows via R2. Here, if you see routing table, see 192.168. Routing table. Show IP route, right? Show IP route. Show IP route EIGRP. See 192.1.2.0 via 12.2. This is the primary path. Via 12.2 is primary. And there is another path via R3, right? And R1 is not consider this path as a secondary path. Here, this path is there to reach 191.2.0 network, but R1 has not selected this path as a primary secondary path. See here, if you see the topology table, show IP EIGRP topology. See, in topology table, it shows only one route, 192.1.2.0 via this path. It's showing only one path. Actually, topology table maintains primary and secondary routes, right? Topology table stores successor route and feasible successor route. But now it's showing only one route. Why? So this is the route. Okay, I will copy this and 1 second. I will explain clearly here. See here. This is the topology table entry for 192.1.2.0 via 12.2. But there is no route for from via 13.3, right? But if it is failed, for example, if it is failed 12.2, if this path is failed, R1 select this path as a best path and see a routing table. See now 192.1.2.0 via 13.2 now. Why? See here, I told you one condition, right? Feasibility condition, FC. FC is what? Feasibility condition. What is the feasibility condition? Advertise distance of backup route, means secondary route. 1 second. Advertise distance of backup route should be less than feasible distance of primary route. This is the condition, right? This is the feasibility condition. See now here, this is the topology table entries, right? See here also we have a two entries in two values in bracket. The first value is feasible distance, second value is advertised distance. This is the primary route, right? This is the primary. Via 12.002 is the primary route. This is the primary and this is the secondary, right? But it is secondary, but actually it is not considered as a secondary. We will discuss that, okay? See here we have a two values, 30720 and 28160. The first value is the feasible distance, the second value is the advertised distance. Here, what is advertised this? What is feasible distance? Feasible distance is, 1 second, I will write here. 1 second, here I will write, okay? Feasible, okay, yeah, feasible distance and advertise distance. Now see here, via R2, okay, via R2, what is the feasible distance? 30720. And what is the advertised distance? 28160. And via R3, what is the feasible distance? See here, 33280. What is the advertised distance? 30720, right? We have discussed in last class, right? See here, FD is used to select the best path. Remember, okay, FD is used to select the best path. Here, the path which has least FD. See here, via R2, FD is 3072. Via R3, FD is 33280. So 3072 is lower value. Then 33280. That's why R2 is selected as a best path. But when EIGRP select R3 as a secondary path, via R3 as a secondary path, it will compare some, right? It will check feasibility condition, whether this route eligible for feasibility condition or not. Now see here, what is the condition? The advertised distance of backup route should be less than, what is the advertised distance of backup route? 3070. It should be less than feasible distance of primary route. What is the feasible distance of primary? 30720. See, now it is equal. It should not be equal and it should be less than. It should not be equal, it should not be greater than. It should be less than. Then only this route become feasible successor. Understand? Very, very important feasibility condition. Okay. Next, last table is interface table. How to see interface table? Show IP EIGRP interfaces. See, these are the EIGRP enabled interfaces. EIGRP enabled interfaces. EIGRP enabled interfaces. F0 by 0, F1 by 0, F0 by 1. See, here three interfaces, right? We have three interfaces. 0 by 0, 0 by 1, 1 by 0. It's showing only these three interfaces. This is the fourth table. These are EIGRP tables. In next section, we will discuss about EIGRP metric calculation.